Hi, I'm Mr. Heng. In this video, you'll learn exponential function but with different base. In your last video, the video 2, you'll learn exponential function with e. So can you still remember the law of indices? So this is the first law. Okay. This is the second law. And this is the third law. So here you have the negative power, negative index, so you know how to change it. And then some more, when you have fractional power, and this is a special property of the law of indices, a to the power 1, we normally do not write down the power 1, we just write down a. So same thing for 12 to the power 1, we simply write down 12. 13 to the power 1, we simply write down 13, that's all. So here is another special property of the law of indices. That means any base to the power 0 is 1. So 35 to the power 0 is 1, and 3 to the power 0 is also 1. So this is the law of indices that you learned early on. So please apply them correctly in the questions. Exponential function at base a is defined by this way. They say a function with a to the power x. So a must be positive and it cannot be equal to 1. X is any real number. So these are the example of exponential function. So 3 to the power x, 1.5 to the power x. So determine the value of f of x for the function when x equal to 2. So you sub in 3 to the power of 2. So I'm sure you can get it mentally. That is 3 squared. 3 squared is equal to 9. So 0.5 to the power of 2. So you sub in, you shall get 0.5 squared. You use your calculator or you work out mentally, you shall get 0.25. So f of x with minus 0.3 whole thing power 2x. When you sub in x equal to 2, you shall get minus 0.3 to the power 4. You will key in this into the calculator. Make sure you have an open bracket with a negative 0.3 to the power 4. As you are aware, when you have even power, negative number will always give you a positive value. So here you have 2 which is outside the bracket. Then in the bracket you have 3 to the power 2x. So you should sub in your x as 2. So you have 3 to the power 4. And you use your calculator or you can work mentally. 3 to the power 81. After that, you multiply by 2, you get 162. Do not take the 2 multiply with the 3 first. That only find the power. That is incorrect. So this is a graph of the exponential function with a any number greater than 1. You see that this exponential function will never meet the x-axis. So this is what we call the asymptote. The domain for this function is from minus infinity to positive infinity, meaning x can take any value. So the range is always positive, it's always greater than 0, and you go right up to infinity. So if you are asked to sketch the graph of 2 to the power x, you shall sub in x as minus 2 in your calculator. You will get the answer 2 to the power minus 2 shall give you 1/4. Same thing for x to the power minus 1. You have 2 to the power minus 1, you shall get half. So when 2 to the power 0, you know it's 1. and 2 to the power 1 is 2, 2 to the power 4 is 2 to the power 2 is 4. You shall get 2 and 4 as the point. So with this viewpoint, you will be able to sketch this exponential graph. When you have the same exponential graph, but after you minus 1, can you state the domain and range? So the graph of this function is actually a vertical translation of the graph 2 to the power x down 1 unit. So this is your graph of 2 to the power x, and the one below is the translations of the graph 2 to the power x moving down by 1 unit. The shape is exactly the same. In this case, you'll see that your y equal to minus 1 is your asymptote. Asymptote is a line where the graph never meet or cross. So the domain, it can take from minus infinity to positive infinity. And the range, you will never meet minus 1. So you will be greater than minus 1 and less than infinity. That is the range. Now let's look at the graph with 2 to the power minus x. State the domain and range. Okay, you may do the table, but if you are familiar, then this graph is a reflection of the graph 2 to the power x in the y-axis. So you'll see that this is your original f of x equal to the power x graph. Then this is the reflection along the y-axis. So this is the graph of y equal to, or f of x equal to 2 to the power minus x. So the domain will always take from minus infinity to positive infinity, and the range is always above the x-axis, so it is greater than 0 and go right up to infinity. So in the previous video, you learned the exponential function. So you also learn how to sub in the value of x equal to minus 2 and so on into your calculator to get all the y value or the f of x value. With this, you will be able to plot the graph or sketch the graph. Just mark the few points. Then in general, we have these few cases. When you have this one, we call it exponential growth. For the next one, this is also exponential growth, but this is refracted. Then this one is exponential decay. And the last one, this is also exponential decay. How do you differentiate? That means when you see the base with the positive power, that will be exponential growth. When you have a base with negative power, that will be exponential decay. So this will be the refractions along the x-axis. This exponential growth is also the refractions along the x-axis. So in this video, you just learn some idea about an exponential graph. If you have any question, please ask during the consultation. This is the end of the video. Thank you, class.